So today we're going to solve three problems in projectile motion in one dimension. So the first problem is the following. A 100-meter tower and a boy throws a stone upward with an initial velocity of 40 meters per second. How long does it take to land on the ground? Now the reason I've chosen this problem is to point out that the entire motion is one of constant acceleration. While it's going up, it's accelerating down at 10 meters per second squared. While it's coming down, it's accelerating at 10 meters per second squared downwards. So since it's a motion of constant acceleration, we can do it in one step. We don't have to break it up into two parts, time to go up and time to come down. Let me show you. Taking up as positive, the total displacement of this stone, remember the stone goes up and then comes back down, and S stands for the displacement, is minus 100 meters, is equal to ut plus 40t plus half, acceleration is a minus 10, remember I have taken up as positive, t squared. So all we have to do is solve this for t, and let's quickly do this. So this is equal to 5t squared minus 40t minus 100 is equal to 0, and that is t squared minus 8t minus 20 is equal to 0. So t is equal to minus b plus or minus square root of b squared minus 4ac plus 80 divided by 2. This is 144 conveniently. Square root of that is 12. So 8 plus 12 is 20. 20 divided by 2 is equal to 10 seconds. So we can do this problem in one step. Now there is also another answer here. 8 minus 12, that is minus 4 divided by 2, that is equal to minus 2 seconds. Now we usually ignore that because the question was how long does it take to land, and that's going to be a positive answer. But does this answer have any meaning? The answer is yes. Because if you look at the equation that we solved, all we put into the equation is at time t equal to 0, the velocity is 40 upward. There nowhere in the equation does it say that the motion starts at that time. So it could have started 2 seconds earlier at time t is equal to minus 2. If I had sent it with sufficient velocity, at t is equal to 0, it could be moving up at 40 meters per second when it reaches the top of the building. You can verify that. So this is also a perfectly good answer to this equation. Our question was, if the boy throws the stone up at t equal to 0, how long does it take to land? Answer is 10 seconds. Let's go to the next problem. In this problem, a boy drops a stone from the top of an 80-meter tower, and 1 second later, he wants to throw a stone down so that it hits the first stone. Here's the important thing. If the first stone has been traveling for t seconds, the second stone started 1 second later, but they met at the same time. If the second stone hits the first stone, that means the second stone has been traveling for t minus 1 second. That is the crucial thing in this problem. Most students get this problem wrong because they put time of travel for the second stone as t plus 1, just because it was released 1 second later. But it actually travels for 1 second less. Now let's first find out how long does the first stone take to travel. Taking down as positive, S is equal to ut plus half a t squared. We have taken acceleration due to gravity as 10 meters per second squared downwards. So t is equal to square root of 8t by 5, that is equal to 4 seconds. So the first stone takes 4 seconds to land. Now the question is, with what minimum speed should the second stone be thrown down so that it hits the first one before it hits the ground? Imagine that the boy throws the second stone with a larger than minimum speed. Then what happens? It'll hit the first stone higher. Even larger speed, it'll hit the first stone even earlier. So for the minimum speed, it hits the first stone as they are about to land. So S for both the stones is 80 meters. Now the first stone takes 4 seconds, so the second stone will take 3 seconds. So for the second stone, again taking down as positive, S is equal to U, that's what we are trying to find out, the speed with which the second stone was thrown, and the second stone travels only for 3 seconds, ut plus half a t squared. 3 times u is equal to 80 minus 45. How much is that? 35. And so u is equal to 35 divided by 3. That is equal to whatever, 11.666 meters per second. That's the minimum speed with which the second stone should be thrown 1 second later. So it hits the first stone just as they're about to hit the ground. Now let's move on to the third problem. So in this problem, an object is dropped from the top of a building and someone sitting inside the building watches the object go by a 1 meter tall window in 0.05 seconds. Question is, how high is the top of the building above the top of the window? So let's say that when the object reaches the top of the window, its velocity is u, downwards. So taking down as positive, the displacement is 1, s is equal to ut 0.05 plus half a, which is plus 5 because 10 downwards positive, half a t squared, 0.05 squared. When you solve this for u, you should get 19.75 meters per second. Now that is the velocity, downward velocity of the object when it crosses the top of the window. Now for the first part of the motion, where it starts at rest at the top of the building and moves down by a distance h, taking down as positive, we can use v squared, which is 19.75 squared, is equal to u squared plus 2a h. So solve for h, you get 19.5 meters. And that's the height of the building above the top of the window. Well, that's it for today, folks. See you in the next video. Bye.